I have the T6 Auxiliary Inverter here, and today we're going to be demonstrating the KEB Motor Learn. Hi, my name is Matt Sherman and I'm an e-mobility sales and applications engineer here at KEB America. The KEB Motor Learn is a tool for getting your inverter paired up with the motor very quickly, requiring only the motor nameplate data. You're going to need values like current, voltage, and torque, and we're going to be putting those values into the COMBIVIS software to learn the motor. COMBIVIS has simple startup wizards for pairing your inverter with your motor very quickly. It has wizards for inputting data into the motor, choosing your feedback mode, choosing your controller, and also doing a motor learn. So in the startup wizards, everything is laid out sequentially. So you'll see first we have to choose our motor. So you have to choose between asynchronous motor or synchronous motor, and the motor we're using right now is a synchronous motor. You can see right now the type plate data isn't correct, so we take the data that we know and we enter that as we need it. So you can see we're changing values like the current, the voltage, the torque has to go to 6.1, the speed is rated at 3,000 RPM, that 1/minute is RPM. We change the frequency to 150 Hertz. We don't have a specific max current, but we're going to set that to 5 because that's what the inverter can handle here. And we set our max torque to 7 Newton meters. With all that done, we also have our temperature sensor, but we don't need that right now, so we're going to choose none. Moving on, we then have our feedback mode. We can choose between open loop and encoderless. The T6 does not need encoder feedback, so we're going to choose encoderless closed loop. Then with the controller, we can set our motor inertia. With the gear that we have on this motor right now, we know that motor inertia is 11 kilograms centimeters squared. You can also adjust the gain down here and the torque limits, but we don't need to change those right now. You can also adjust your controller performance, but we don't need to adjust that either. So then you have your protection, and everything here should be set up correctly by default. And from there, we can actually go into the motor identification. So we're going to hit restart identification and verify that we chose our data correctly. So we'll confirm that type plate data. We can then choose the EMF detection, and we do want to do that because that'll allow the motor to spin. Here you have the option to either select or deselect the EMF detection. If you select it, that'll let the motor run and it'll measure the EMF for the motor model. You do have the option to deselect it and to actually add that data in later, but it's easiest to actually let it run while you're doing the motor learn. And then we verify that our digital inputs are correct. There are no digital inputs on the T6, so we don't need to do anything with that. Then we verify that our error state doesn't have a fault logged in it right now. And now we're getting ready to start the motor identification. This process will take approximately 2.5 minutes. And get ready for a loud noise. Nothing's going to break. This is just the motor learn doing its job. So those loud noises you could hear, that's the motor identifying the inductance. And now it's going through the stator resistance. These are all values that are typically very difficult to find in the actual motor documentation. So this is where it's very useful to be able to just put in the basic motor nameplate data and let the motor figure out the rest. You can see right now it's running its tests, and now it's going into a dead time measurement. You can see it'll show the current status up here, and it'll show the old values down here and how the motor is updating those here. So then it's doing this then so it can actually run an sensorless closed loop as we discussed. That's a version of motor control for the T6 that actually doesn't require any actual encoder feedback. Instead it's using values like the motor voltage and the current, and then actually combining those with a sophisticated motor model and running calculations to actually close that loop instead. So it's running in very accurate closed loop operation with no additional hardware. And you can see up here we selected EMF detection. So this actually does mean the motor is going to run during this process. That's why it's important right now to make sure that it doesn't have any additional load. It is okay to run it without the EMF detection. You will get the information that you need. It just won't have the most accurate result. And right now it's doing a rotor detection, and the motor is going to spin then to identify that EMF. And the motor learn is almost complete. You can see at any time we do have the option to abort the identification. And now the motor learn is completed. We have the option then to either confirm the identified values or discard them. The motor learn did complete successfully, so we are going to confirm those values. Now that we've completed the motor learn, we'll do a test run. We'll pull up the test run window and hit start, and we'll watch the motor run in centralist control. If you'd like to learn more about that, we have another video in this series that goes into more detail. And if you run into any problems, you can go into the Help tab and click on KEB Quick Support to get help from a KEB engineer to help you with your project.